Hello everyone. In this video we're going to be looking at an exponential equation. We have e to the power x plus ln x equals 2 times e squared, and we're going to be looking for x values. I'll be presenting two methods. Let's start with the first one. For my first method, this is something that we commonly use. I'm going to ln both sides. If you do, you get the following: ln e to the power x plus ln x equals ln 2e squared. So I'll be showing two methods, and at the end of each method, I'll be showing you a graph. So the graph kind of explains what's going on as well. Now, using the properties of logarithms, we can go ahead and move this to the front, and that gives us x plus ln x multiplied by ln e, which is equal to 1. So we don't have to worry about it. And the expression on the right hand side can be broken down into a sum. So we can write this as ln 2 plus ln e squared. And this power can be moved again, which gives us 2 times ln e, which is equal to 2. So we can basically write this as x plus ln x equals ln 2 plus 2. Now, I can write it in a nicer way. How about writing this as x plus ln x equals 2 plus ln 2. Now, if you compare these two expressions, you'll quickly notice that if x is equal to 2, then this equation will work, because we have an x here and we have a 2 here. So they will correspond nicely. But there's a couple of things we need to talk about. For example, this looks like a solution, but is that the only solution, right? How many solutions are there? So here's what we're going to do. We're going to look at it from a functional perspective and consider the function f of x equals x plus ln x. Now, first of all, notice that because of ln x, x needs to be positive. So we're only going to be considering the positive values of x. Let's go ahead and differentiate this function. We get 1 plus 1 over x. And since x is positive, this is also going to be positive, which means f of x is always increasing. Of course, we're talking about the positive x values, but on that interval, it is always increasing. Great. That means we only got one solution because we have a function that's always increasing. I'll show you the graph of it in a little bit, and it's being intersected by a horizontal line. So this is a constant, therefore, y equals 2 plus ln 2 is the graph of a constant, which is a horizontal line. All right, great. So let's go ahead and take a look at the graph and see visually what this looks like. So we have y equals x plus ln x. By the way, as x approaches 0 from the right, we have an asymptote at 0. Y values are going to approach negative infinity. And as x approaches infinity, y is going to approach infinity. And our graph is kind of going to look like y equals x, because x is going to grow faster than ln x. ln x is the inverse of e to the x, which grows faster than x, but its inverse is going to grow much slower. Not much slower, but just slower. Let's say, put it that way. And you can see here on the graph, we have y equals x plus ln x, which is the, is that blue, green? Yeah, I think it's blue. And y equals 2 plus ln 2, which is the horizontal line. And they happen to intersect at 2 comma 2 plus ln 2, which means x equals 2 is the only solution to this equation. Awesome. Let's go ahead and take a look at the second method, and then we'll look at the second graph. For my second method, I'm going to start off with the original equation one more time. E to the power x plus ln x equals 2e squared. So basically what we found out was that x equals 2 satisfies. When you look at an equation like this, it's not directly clear that x equals 2 is going to work. So we're going to put it in a nicer form. And this is what I'm going to do. I have the two exponents being added. So I can kind of write it as a product, because remember the rules of exponents. If you're multiplying two exponents with the same base, then you multiply the exponents. So we can write it like a to the power x plus y. So we can do the opposite. We can kind of split them up. And that becomes e to the power x multiplied by e to the power ln x. And that equals 2e squared. But what is e to the power ln x? We understand e to the x it's the exponential function. But what about e to the power ln x? Well, e to the power ln x by definition is equal to x. Of course, x needs to be positive, so on and so forth. We already talked about it. So this is x, and from here we get x times e to the power x equals 2 times e to the second power. By the way, if you want to see why e to the power ln x is equal to x, you can do the following real quick. E to the power, suppose we don't know what e to the power ln x is, let's call it y, and then ln both sides. Ln e to the power ln x equals ln y. Ln x is a power, so we can kind of move it forward or to the front, and that gives us ln x times ln e, which is 1. So from here we get ln x equals ln y, which implies x equals y, or y equals x. And this shows that e to the power ln x is equal to x, therefore our equation is valid. So we ended up with something like this: x times e to the power x equals 2e squared. Again, we can ask the same question. So the question is, we kind of see the solution here, right? Hopefully you do, and if you've seen the first method, you also know the solution. But it's kind of not too hard to see that x equals 2 is going to work, right? But the question is that the only one? So let's go ahead and explore a little further. This is my equation, and x equals 2 works. So that's a solution. But is that the only solution? Let's find out. So we're going to define this function g of x equals x e to the x, and then differentiate it, g prime. This is a product, so we're going to use the product rule to differentiate. The derivative of x is 1 times the second function, plus the derivative of e to the power x, which is itself, times the first function. And a lot of times we're going to, with these kinds of things, we're going to set it equal to 0 to find the critical points. I'm going to show you quickly what that looks like before I show you the graph. So this can be written as e to the power x multiplied by the quantity 1 plus x. And if you set this equal to 0, you're going to get x equals -1 from here. Great. What is that supposed to mean? It means x equals -1 is a critical point. But is that a maxima or minima? We need to make a table or use the second derivative test. Some people find the second derivative test easier. It's totally up to you, but a lot of times I'll use the table, and guess what? I'm going to do the second derivative test this time, okay? Just for the sake of change. So you're going to differentiate a sum, but you already know the derivative of e to the x is e to the x, and the derivative of e to the x times x is what we got for the first derivative. So I can kind of add it to this plus this, and that just gives us an additional e to the x, which can be taken care of by, just factoring out the e to the x again, just like the same with the first derivative. Okay, what does this give us though, right? We're going to set it equal to 0 now. That is for inflection point. We don't need to worry about that. But let's go ahead and see what happens when I plug in this first derivative value into the second derivative, because if you get a positive value, so here's what happens. If you replace x with -1 in the second derivative, they're going to get e to the power -1 times 1, which is basically a positive value. And the positive value means you're going to have a minimum. Why is this a minimum? Because this basically shows you the concavity. This is concave up, therefore it is going to make a minimum. And if you graph the function, and I'll show you the graph of it, you'll have a better idea why we got that value. And here's what the graph looks like. The graph of y equals x to the power x times e to the power x. And as you can see here at -1, we have a minimum. But the whole idea is this is going to intersect 2e to the second power, which is not in this graph, by the way, because in order to zoom in a little bit, I had to kind of get rid of that. But you get the idea. Horizontal line is going to intersect at one point. But if you were looking for a very small y value, even something less than 0, you would be looking sometimes for 2 solutions to this equation. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.